Hello friends, so now we are going to solve a very popular LeetCode problem called minimum cost to climbing stairs. This is the subsequent question to another popular LeetCode problem called just climbing stairs. So let's understand the problem statement. Basically, we are given an integer array called cost where every single value inside this array represents the cost of to reach to that particular step in a staircase. Now, once you pay the cost, you can either climb one or two steps. The question is that we can either start from the very first step or the second step, so the 0th index or the first index, and we need to return the minimum cost to reach to the top of the floor. So let's try to understand this with couple of examples. First example is that let's say that we are given an input array like this that contains three entries 10, 15 and 20. Now we can see in this case that if we take one jump straight to the 15, now again from this 15 we have two options. We can either take a jump that directly goes to 20 or we can take a jump that directly goes above 20. So basically we are able to reach to the top floor. So in this case the answer is quite obvious that if we are able to reach to 15, we can reach to the top floor very easily without paying any extra cost. So 15 would be the minimum cost that we need to pay in order to reach to the top floor. Let's take one broader example. Now we can see that this staircase has 10 different entries and every single step contains a different price. The idea would be if we decide to take two jumps in this case, which would be the greedy approach, it wouldn't work because we would incur a cost that is 100. Rather than it would make sense for us to take one jump at this position number 1 with cost 1 and then take two jumps. Now once again when we are at this position, once again it would take sense to take two jumps because once again the cost incurred would be 1 and once again taking two jumps. Now after taking two jumps, once again it would not be wise to take two jumps directly because we would be encountering cost 100. Rather than that, we can actually take one jump and incur this cost 1, and through this 1 we can also skip over this 100 and take two jumps and reach to 1. So in total we are only taking 6 jumps with each jump costing us 1 unit. So in this case the minimum cost we need to pay in order to reach to top would be 6. So this is what we need to return. So the very first approach that comes to our mind is a very simple brute force approach. The logic is quite straightforward that we actually calculate every single possibility. So we calculate a possibility like this, then we start to calculate the possibility like this, that taking one jump and then two jumps and three jumps, and then we calculate the possibility like this and then this and then this, something like this. So overall across all the possibilities eventually we would find a pattern that contains the minimum cost, but this is a very inefficient approach. We can clearly see why, because we are doing repeated work lot of times in order to comprehend the solution. We can solve this problem in n square time using the brute force approach, but this is still very inefficient. So let's try to see a better approach there where we can actually solve this problem. So now to solve this problem we are actually going to use the most beautiful thing in the computer science and one of my favorite topics, that is dynamic programming. Why we are choosing dynamic programming to solve this problem? Well, first let me give you a very clear logic. If we have to choose any particular value, we will have to make the decision based on the previously calculated values, and based on that we would be able to define that what is going to be the minimum cost to reach to this step. Now currently what I'm suggesting is that we use a bottom up approach. So we go from the very first entry to the very last entry, and at every single step we simply calculate that if we have to include this step, what is going to be the minimum cost associated with this step. And let me show you what I mean. So currently we have no choice but to calculate that what is going to be the minimum cost to reach to these two values, and it's quite straightforward. We can always directly make jump to this very first step or very second step. So we can create a dynamic programming array, and the purpose of this array is going to be that we will calculate that what is the minimum cost it takes to reach to any particular element. And we know that for sure the minimum cost is always going to be these two values for the first two entries, because we can either take one jump or two jump. So let's just mark these two. But now when we come to this position, we have two options. Either we take one jump at this step number 5 and then two jumps directly to step number 3, or we take one jump directly to this step number 1 and then take one jump over here. So if we have to calculate the dynamic programming of this value, so let's say that this is currently index position 2. So this is 0, 1 and 2. Okay. So the dynamic programming equation is going to be quite straightforward. That dynamic programming of 2 is simply going to be cost plus dp of 1, or cost of that this cost defines the current cost of this index. Okay. Cost plus dp of 0. So in this case, and whichever is the minimum value, we will pick that. So this equation is going to give us a lot of interesting results and build our dynamic programming array. So let's try to see our solution for the minimum cost it takes to reach to this step with value number 10. One option is that we do cost plus dp of 1. We know that dp of 1, the value is 1, so this is going to be value 11. And second one is cost plus dp of 0, so this is going to be 15, and whichever is the smaller, we are going to pick this. Which means if we have to use this step 10, then the minimum amount of work we will have to do is going to be 11. There is no other option, so we will just fill that value up. Once again, with this value number 2, we are going to repeat the same operation, and basically the logic is once again going to be quite straightforward. That cost at 2 is going to be dependent on these two entries, so 2 plus 11 or 2 plus 1. So 2 plus 1 is 3, so obviously it makes sense for us to give the answer as 3 and not 11. So we'll mark this entry. And once again, this is the top position, so once again the top position, the value is 1. Now if we have to include this one or not to include this one, once again the logic is quite straightforward. We are going to compare the values of the previous two entries which we have already stored, and that is 3 and 11. So once again, if the total is going to be 4, that is the smallest entry we need. Now notice that we have the option to choose the minimum cost amongst these two entries. So whichever is the smaller value amongst these two is the one we are going to pick for the answer, because you can go to the top from this 2 step as well, and you can go to the top from this 1 step as well. So once again, the minimum of these two is going to be 3, so we are going to return 3 as the answer in this case. And this is the whole logic I'm suggesting to solve this problem. Now ideally, I created this dynamic programming array to solve this problem, but you actually don't need to have an entire array dedicated to solve this problem. You can actually just store all the entries in 2 variables, so you can also save so much time, so much space in terms of space complexity as well. Now let's try to calculate that what is going to be the time and space complexity for our optimal approach. Time complexity is going to be big O of n, because we are iterating over the given input array just once. And space complexity, well, obviously if you decide to use a dynamic programming array, then it's going to be big O of n, but if you just use 2 pointers, it can also be big O of 1 as well. So now let's see the coding solution for this one. So the coding solution is quite straightforward. First, we are checking for 2 edge cases, that if the given input only contains 1 or 2 stairs, then we can simply return those values accordingly. If that is not the case, we are just simply using 2 variables, first and second, and we would be updating these 2 variables continuously. Now we are starting our loop starting from the third step, or I is equal to 2, to the very end of the given array. And we are simply doing a very simple calculation. We are checking that what is the current cost for the current step or current ith value we are at. For that, we are defining a new value, and we are simply calculating that what is going to be the minimum value of the first or second plus the cost of the current value, cost of I. Then based on that, we are updating the values of our first and second. So now our first value is going to become the second value we had, and our second value is going to become the current value we had, which is quite straightforward, quite simple to understand. And after the end of our loop, we are simply checking that what is going to be the minimum value amongst first or second, and we can return that as the answer. So let's try to run our code. Seems like our solution is working as expected. Let's submit this code. And this is beautiful. We beat 100% of all the other solutions, and that's because this problem actually runs in 0 milliseconds. so no surprises there. But important thing is that look at the time complexity we are saving, or sorry, space complexity we are saving, where we are beating almost 90% of all the other solutions. So our solution is one of the best solutions on LeetCode. That's because we are using two variables. So once again, the solution of this code is present in our GitHub repository. Feel free to go ahead and check it out. Thank you.